They readily lose one electron to give monovalent M plus ion. General electronic configuration of alkali metals is Ns1 and alkaline earth metal is Ns2. The removal of electron from the outermost shell will be called it as ionization energy. That S block elements having two categories, that is alkali metals and alkaline earth metals. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up a new chapter, that is S block elements. First we will see the exam corner. The number of periods which is required to complete this chapter is 6 periods or 6 hours, and the marks allotted for this chapter is 5 marks. Today we will discuss about the general introduction part of S block elements. In that, group 1, that is alkali metals, physical properties and chemical properties of alkali metals will discuss in this session. First we will see some of the introduction about S block elements. We know that periodic table has been classified into 4 blocks, that is S, P, D and F block. In this chapter completely we are studying about S block elements. That S block elements having two categories, that is alkali metals and alkaline earth metals. In this session we are discussing about alkali metals. Okay. The S block elements are those in which the last electron enter into the outermost S orbital. First and second found in S orbital. These electrons are easily lost to form positive ions except helium and hydrogen. But groups of the periods table belongs to S block elements. In their ground state, the highest energy electron in helium configuration is chemically exceedingly stable and it has no known stable compounds. Hence, it is grouped with the noble gases. And the first two groups, that is first group and the second group, will be considered as S block elements, and the last electron in the electronic configuration will reach to the S orbital only. So, these elements will be considered as S block elements. And here the elements which are present in the S block, it tends to lose the ions, so it will form positive ions easily except helium and hydrogen. But groups of the periodic table belong to S block elements. In their ground state, the highest energy electron in the helium configuration is chemically exceedingly stable. In that, helium configuration is very much stable and has no known stable compounds, hence group with the noble gases. The elements of group 1 except hydrogen are called alkali metals because these metals forms hydroxide when they are react with water, which are strongly alkaline in nature. Metals or group 1 elements will be considered as alkali metals except hydrogen because these will form hydroxide when they are treated with water. And they are strongly alkaline in nature. Alkaline means basic in nature. The elements of group 2 except beryllium are called alkaline earth metals because their oxides are alkaline and these metal oxides are found in earth's crust. When the group 2 it forming oxides, and it will be regarded as alkaline in nature and it is mainly found in earth's crust. So, group 2 will be considered as alkaline earth metal. Next, general electronic configuration. The general electronic configuration of alkali metals is Ns1 and alkaline earth metal is Ns2. Okay, this is 1 to 2, and for alkali metal Ns1, for alkaline earth metal Ns2. Okay, see here, for lithium if you take 3, 1s2 and 2s1, this is Ns1. And if you take sodium, if you take potassium, rubidium, cesium and francium, all will end up with S1. And here if you take beryllium, what will happen? 1s2, 2s2. And if you take magnesium, calcium, strontium, barium and radium only, and everything will end up with Ns2. This is having Ns1, this is having Ns2. And occurrence, among the alkali metals, sodium, potassium are abundant and lithium, rubidium cesium have much lower abundance, francium is highly radioactive. In the S block elements, sodium, potassium are very abundant in nature. Lithium, rubidium, cesium have much lower abundancy and francium is highly radioactive. Of the alkaline earth metals, calcium and magnesium rank 5th and 6th in the abundance respectively in the earth crust. In the alkaline earth metal, if you see, calcium and magnesium are 5th and 6th position in the earth crust, which is abundant in nature. Strontium and barium have much lower abundances, strontium and barium. Beryllium is very rare and radium is very rarest. Radium and francium are radioactive in nature. In S block elements, radium and francium are radioactive, beryllium and radium also rare and rarest. Next, group 1 elements, that is alkali metals. Group 1 of the periodic table consists of elements hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These are the group 1 elements. The electronic configuration, alkali metals have one electron in their outermost s orbital preceded by noble gas configuration. Will enter the last electron into the s orbital. Thus, the general configuration of alkali metals may be written as NS1. N represents the valence shell. They readily lose one electron to give monovalent M plus ion. Metals means it readily give one of the electrons or it readily loses its electrons in the valence shell. So, it will form M plus ion, that is cations will form because it is electropositive in nature. See here the electronic configuration, lithium symbol is Li, atomic number 3. This is electronic configuration after helium 2s1, sodium Na, it is 11, atomic number, neon 3s1, potassium K 19, after argon 4s1, rubidium Rb 37 is the atomic number, after krypton 5s1, cesium Cs 55, after xenon 6s1, francium Fr atomic number 87, after radon 7s1 is the electronic configuration. Next, ionization enthalpy or ionization energy. The first ionization energy of the alkali metal is the lowest as compared to the elements in the other group. The ionization energy of alkali metal decreases down the group. If you see down the group, that ionization energy will be decreased and also the first ionization will be the least ionization energy. What is the reason? The size of alkali metals is the largest in their respective period. So, the outermost electron experiences less force of attraction from the nucleus and hence can be easily removed. Why decreased in the down the group means, as we down the group in the periodic table, the size of the alkali metal will get increased. When the size of alkali metal will be increased, the force of attraction between nucleus and the outermost electron will feel or will experience very less. So, the outermost electron can be removed easily. What is the meaning of then ionization enthalpy or ionization energy? The removal of electron from the outermost shell will be called it as ionization energy. Whenever it is more, then it can be removed easily. The value of ionization energy decreases down the group because the size of metal atom increases due to the addition of new shell along with the increase in the magnitude of screening effect. The value of ionization energy decreases down the group. Why means the size of the metal atom increases and also shell will also get increased. The shielding effect or the screening effect will also experiences there. The second ionization energies of alkali metals are very high. The removal of an electron from alkali metal causes the formation of monovalent cations having very stable electronic configuration, same as that of noble gases. Therefore, it becomes very difficult to remove the second electron from the stable noble gas configurations, resulting in very high second ionization energy values. The second ionization enthalpy will be more comparative to first ionization enthalpy. See here, first is 520 means second will be 7298. If it is 496, 4562. If 419 for potassium in first ionization enthalpy means 3051. Other examples also, first ionization enthalpy is less comparative to second ionization enthalpy, because the second one is having more electronic configuration, that is stable electronic configuration. To remove that, it needs more energy. Next, hydration enthalpy. Due to increase in atomic size, hydration enthalpies of alkali metals decreases down the group. Due to increase in atomic size, hydration enthalpies of alkali metals decreases down the group. The alkali metal ions get extensively hydrated in aqueous solutions. Smaller the ion, more is the extent or degree of hydration. Thus, the hydration enthalpy radii in aqueous solution follow the order. Smaller the ion means more is the extent of degree of hydration. That's why lithium will be having more hydrating power than sodium, than potassium, than rubidium, than cesium. The charge of density on lithium is higher in comparison to other alkali metals due to which is extensively hydrated. Next, atomic and ionic radii. The atoms of the alkali metals have the largest height in the respective periods. So, the atomic radii increases on moving down the group among the alkali metals. Down the group, size will increase, that we know, and also ionic radii also getting increased. Reason, on moving down the group, new shell is progressively added. Down the group, the new shells will be keep on adding, that's why the size will also increase. Although the nuclear charge increases down the group, but the effect of addition of new shells is predominant due to increasing screening effect of electrons of the inner shell. Hence, the atomic size increases down the group. New shell will increase, nuclear charge will also increase, and also screening effect will also increases. Alkali metals change into positively charged ions by losing their valence electron. The size of cation is smaller than the parent atom of alkali metal. However, within the group, the ionic radii increase with increase in atomic number. Atomic radii of monovalent ions is less than the parent atom. What they are telling? They are readily lose one electron from the valence shell. The cation, the size of cation will be less than its parent atom. So, see here, physical property, atomic radius is 152, ionic radius is 76. Always ionic radii is smaller than atomic radius. Next is physical properties of alkali metals, that is flame test. The alkali metals and their salts impart a characteristic color to flame. In the salt analysis, if you have observed from calcium, magnesium, strontium, barium, this will impart a characteristic color. By seeing that color only, you can identify this salt or this ions are present in the given salt. And what are those colors? Lithium crimson red, sodium golden yellow, potassium pale violet, rubidium violet, cesium sky blue, and still barium, strontium are there, brick red and apple green is also present. On heating an alkali metal or its salt, the electrons are excited easily to higher energy levels because of absorption of energy. When these electrons return to their ground state, they emit energy in the form of radiations which fall in the visible region, thereby imparting a characteristic color to the flame. This property makes cesium and potassium useful as electrodes in photoelectric cells. Whenever the heat is projected or produced to the salt, the electrons will move into the excited level and come back to the ground state. Whenever it is come back to the ground state, it will leave some radiation in the visible region. That visible region imparts the color to identify which salt is there. Next chemical properties. The alkali metals are highly reactive and reactivity increases down the group. Highly reactive means that is less stable in nature. So, down the group reactivity increases. The reactivity is due to low value of first ionization energy, large size, low heat of atomization. These are the three reasons why the reactivity is higher in S block elements. First one, reaction with air. The alkali metals tarnish in air due to the formation of an oxide or hydroxide on the surface. We know that alkali metals will form hydroxides as well as oxides. Whenever it is reacting with air, it forms oxides, also hydroxides. Alkali metals when burnt in air form different kinds of oxides. For example, the alkali metals on reaction with limited quantity of oxygen form normal oxides of M2O. This is oxygen reacting with oxygen, 2M2O will form. M can be lithium, sodium, potassium, rubidium or cesium. This is how the alkali metals react with air. It will form usually oxides. When heated with excess of air, lithium forms normal oxide, that is Li2O, sodium forms Na2O2, where potassium, rubidium and cesium form superoxides having general formula MO2. Lithium plus oxide, lithium oxide, sodium plus oxide, sodium peroxide, metal and oxide, that can be potassium, rubidium, cesium, it form superoxide, then potassium will form potassium superoxide. The oxidation state of potassium in KO2 is +1 since it contains superoxide ion O2-. The reactivity of alkali metals with oxygen increases down the group due to the increase in stability of peroxides or superoxides. In all these oxides, the oxidation state of the alkali metal is +1 oxidation because it can lose its 1 electron from the valence shell, so its oxidation state is +1. Lithium shows exceptional property in reacting directly with the nitrogen of air to form the nitride Li3N. It is the exceptional case. Because of their high reactivity towards air and water, they are normally kept in kerosene oil. We know that sodium or potassium will kept in kerosene oil because it will react with air very soon. Reaction with dihydrogen. Alkali metals react with dihydrogen at 673 Kelvin to form colorless crystalline hydrides. All the alkali metal hydrides are ionic solids with high melting points. With high melting point, it will react to form crystalline hydride. Metal with dihydrogen in the presence of heat, metal hydride will form. Metal can be lithium, sodium, potassium, rubidium or cesium. Next, reaction with water. The alkali metals are known to have large negative reduction potential values. It is having large reduction potential values. As a result, they can act as better reducing agents as compared to hydrogen. Hence, alkali metals react with water to form hydroxide by liberating H2 gas. Metal plus water, see, metal hydroxide plus hydrogen gas will be liberated. Sodium, for example, plus water, sodium hydroxide plus hydrogen gas will be liberated. The reaction becomes more and more violent as we move down the group. Thus, lithium reacts gently, sodium melts on the surface of water and the molten metal moves vigorously and may sometimes catch fire. Potassium melts and always catches fire, and so are rubidium and cesium. What? Sodium melts on the surface of water. On the surface of water it will melt and molten state of metal will vigorously catches fire, so it will be kept in kerosene. Next, reaction with halogens. Halogens means you know that is group 17. Alkali metals react vigorously with halogens to form metal halides of general formula Mx, which are ionic crystalline solid. M plus, that is metal plus halogen, it will form metal halide. Metal can be lithium, sodium, potassium, rubidium, cesium. Hex halogen can be fluorine, chlorine, bromine or iodine. Reactivity of alkali metals with particular halogen increases from lithium to cesium. On the other hand, reactivity of halogen decreases from fluorine to iodine. Solubility in liquid ammonia. All alkali metals dissolve in liquid ammonia, giving deep blue solutions which are conducting in nature. These solutions contain ammoniated cations and ammoniated electrons are shown below. See, metal plus ammonia treating with ammoniated cations are forming and anions also forming here. The blue color of the solution is due to the ammoniated electrons which absorb energy corresponding to red region of the visible light. Why that blue color will be imparted? Because the electrons has been absorbed the energy of red region of visible light for their excitation of higher energy levels. The transmitted light is blue, which imparts blue color to the solutions. The electrical conductivity of the solution is due to the both ammoniated cations and ammoniated electrons. The blue solution on standing slowly liberates hydrogen gas, resulting in the formation of an amide. NH2 is amide. Next, reducing property. We know that alkali metals are having more reducing properties. How? The alkali metals have more negative values of reduction potential and therefore have a strong tendency. However, lithium is the strongest reducing agent due to the large enthalpy of hydration of cation, lithium ion, lose electrons and act as good reducing agent. The reducing character increases from sodium to cesium. From sodium to cesium, it will increases. The alkali metals have low value of ionization energy which decreases down the group, so can easily lose their valence electron and thus act as a good reducing agent. It is having low ionization enthalpy, so decreases down the group and it can lose electrons from its valence shell easily. By that we can tell it is a good reducing agent. Because of the high reactivity of alkali metal towards the air, water, alkali metals are stored in kerosene. Next, uses of alkali metals. Lithium metal is used in make useful alloys. For example, with lead to make white metal bearings for motor engines, with aluminium aircraft parts, with magnesium to make armor plates used in the thermonuclear reactions. Alloy means the mixture of metals, the homogeneous mixture. Whenever lithium is mixed with lead, it forms white metal used in the motor engines. When lead is mixed with aluminium, aircraft parts. When lithium is mixed with magnesium, armor plates which is used in thermonuclear reactions. Lithium is also used to make electrochemical cells also. Sodium is used to make sodium lead alloy needed to make a tetramethyl lead. These organo-lead compounds were earlier used as anti-knock additives to petrol, but nowadays vehicles used lead-free petrol. Liquid sodium metal is used as a coolant in fast breeder nuclear reactors. Potassium has a vital role in biological system. Potassium chloride is used as a fertilizer. Potassium hydroxide is used in the manufacture of soap. It is also used as an excellent absorbent of carbon dioxide. Cesium is used in the devising photoelectric cell. Most of the in alkali metals, lithium is abundant and it is used in various industries. In the next session, we will discuss about anomalous properties of lithium, diagonal relationship, general characteristics of the compounds of alkali metals. These are the contents we will discuss in the next session. I hope you have understood the introduction and the physical chemical properties of alkali metals. We will meet in the next session. Thank you.